Welcome to part two. In this section here, we're going to be speaking about the actual testing project. Okay. The first part we covered the production code, our production code that we're going to be testing with all the folders here, bank, math, and service. I've explained that on part one. If you guys have missed that part, please just go to part one so that we can dive deep into the testing basic.test now. We're not going to look into the production code for now. Okay, so with regards to our testing project is named the same way as the production code, except at the end we put the .test. I've already explained that why I did that. Okay, so when I expand this here, you will notice that this project here is also similar to this project in some sense, in that I have the banking folder and I have the math folder as well. Well, I don't have the service folder there because I don't necessarily have the testing related, or rather the test related to that service folder, right? Okay, so this is the reason behind this. Whenever you create a project, you want to make sure that your testing project also kind of mirrors your production code kind of structure, okay? To make it easier for people to navigate through. So if I know that, okay, for example, there is a banking application here. When I want tests related to that banking application, when I come in here, I know that this is related to that. Likewise with math. So that's how you make it easy for you or for anybody else that's going to be, working on the same project as you, so to say, or maybe later on when you're not around, okay? So that's that. And even when I open this file here, okay, this folder and open this file, the bank account.cs, I will do the same here, open that, and when I come here, it's the exact same thing, bank account.cs.test. You will see that we have like the same naming convention, but obviously the code in here now is related more to testing as opposed to the one that you saw inside our production code. Okay, so in this section here, I'm just dedicating this to explain this code here, okay? So if you think about it now, we said our our unit tests are for this specific code here, this specific class, this specific file, bank account. So also here we have bank account tests. So these tests are only related to this bank account here. Okay. So we said we're going to take the deposit method as the first method to test. And if we look at this, we go in here. We also have the deposit testing of the deposit here. So I'm going to show you, or rather explain to you guys, what all these things are. You can see fact. You can see that the names of the methods here are also awkwardly named. And we can see things like assert over here. And you might ask yourself, what is SUT? Okay, because the convention of variables dictates that your variables names should be meaningful, so to say. So you'll see why that is the case. Okay, so let's first start off by saying this. We are using XUnit. That's the first thing. We're using XUnit as our testing framework, okay? And the reason that is because it works very well with .NET Core. And hey, if you create a test project within the Visual Studio here, you will see that XUnit is there. So the heavy lifting that you had to do before, where you had to manually bring in the packages, is not there anymore. So XUnit is much more easier to work with. I mean, I've worked on NUnit. It's also easier to work with. So, but XUnit is more preferred for .NET Core applications and going forward. Okay, so that's what I'm going to be covering here. So when you look at XUnit, or a testing framework for that matter, it doesn't need to be XUnit, for example. XUnit call our tests facts or fact, okay? And I think in NUnit you call them tests. It's been a while since I used NUnit. So you have to mark your methods as fact on XUnit, whereas I think there you mark them as test. And the reason behind this is this. If you just write a method, for example, like this here, and you don't put in fact to indicate to XUnit that this is a test method. XUnit 1 know whether that this is a test method, okay? Well, or it might know, but your test runner here won't pick it up. So therefore, it's very much useless because it's not recognized as a test method, okay? So in order to make sure that your methods are recognized as test methods, you need to mark them. This is called marking. So right on top of your method here, you mark it as effect. And that's how Visual Studio will be able to pick this up as a test. So later on, you'll be able to come here and be able to right click on your, let me just expand here, right click here and run. If you don't do that, you won't be able to, okay? That's what XUnit does for us. It provides us with these marker methods here, the markers methods. We'll be able to mark them. And also, it gives us this static classes here that has methods like .equal, and it's many of them really. It's not just equal method here. We have contains, we have does not match, and all of that, right? So basically what those allow us to do is they allow us to affirm or to confirm or to assert that what I'm saying or what's supposed to happen is actually happening. What do I mean by that, okay? When you test, if you think about it, when you test something, you expect it to behave in a specific manner. So to say, typical example, you go to your car, you want to test if your car starts up. What is the first thing that you do? Okay, I'm going to go past opening the doors of your car and sitting down and adjusting your seat and putting the car keys into the ignition. But turning the car keys is your actual test, right? You are turning it, and once it turns on your car, you hear the car engine comes up, right? That coming up is basically you now confirming, oh, it's actually coming up. If it doesn't, then you have a problem, right? And that's when you know, oh, the car is not actually doing what it's supposed to be doing, or the engine is not doing what it's supposed to be doing, turning on. So you have the expected behavior. So the expected behavior is that the engine must come up with a little bit of noise and then it turns on. The expected behavior is that the engine turns on. And if it doesn't, then you have a problem. Okay, so in that car scenario, would actually say we are asserting that the car engine turns on. So it'll be assert dot engine on or something of that nature, or assert that car engine start up or something of that nature. So asserting is basically making a bold statement that that is actually happening or might not be happening, whatever the case might be. So in our case here, just think of assert as confirm. So we are confirming that our balance is equal to what we expect here. So if you look at our equals method, for example, it takes expected and equal. Because there's no point in testing something and you don't have an expectation. So you must always have an expected value or an expected behavior. So that expected behavior kind of guides you on how to, or rather kind of guides you to say this is doing what it's supposed to be doing, period. That's basically that. So this is what we're doing here. So if you look at that, it says assert. So think of that as, you know, I'm confirming, boldly confirming that, and then this here, our actual is equal to our sorry about that. Our actual is equal to our expected. Let me do that so you can see that again. Our actual is equals to our expected. So that's basically how that works. Confirm that our expected is equal to our actual is equal to our expected. That's basically that. So let's go back now into this here. You will see that I have arrange, act, and assert, okay? What does that mean? Okay, so firstly, before we test, we need to start up to do our little bit of our preparations up front, okay? The scenario that I gave you about when you want to test if your car start up. You're not going to go inside your car if your doors are closed and unless you want to go through the windows. But also if the window is closed, you're not going to go through into your car, right? So the first thing that you want to do is this. You want to start up by, okay, I'm going to the car. I'm opening up the door of the car. I'm adjusting my seat. I'm sitting down, and then I'm putting in the car key in the ignition. So those steps that you did there, right, form part of the arrangement, okay? That's your arranging, that's your setup. So you haven't yet started testing what you need to test, but that is the beforehand job that you have to take, okay? The task that you have to perform before you do the actual task of testing. So you need to, those are your prerequisite basically. It must be that you are in your car, you could turn on the car key without without sitting down, but I'm just saying, okay, you have to make sure that all of those prerequisites are in place before you turn on the ignition. So it's the same thing here. We're going to be testing our bank account, right? So we need to for starters, to make sure that we have an instance of a bank account and it has the balance. It can be zero, it can be anything, but the balance has to exist first, okay? Then this is the part of it. I mean, it could have been that you need more than that, but for now you just need to create the account, okay? And let it exist first, okay? And we called it SUT here. Why didn't I call it bank account? You can simply call it that. I mean, we are told that, for example, let me do that. Okay, we are told that if your class here is bank account here, I mean, obviously your variable here need to be something along those lines so it makes sense to the reader of the code. And for code readability, it's supposed to be that, okay? But if you think about this here, in this scenario, what are we doing? We are testing bank account, okay? Bank account. So anything inside bank account here, that's what we are going to be testing, okay? So to me, it's pretty much obvious, and to anybody, when you look at bank account tests, it's pretty much obvious, okay, that these tests are related to the bank account class. These are the unit tests for that class specifically, okay? That's basically that. So hence it will make no sense. Well, it will make sense, but it's more of a repetitive nature, or it's redundant rather, so to say, okay, for me to call it bank account here. So why do we call it SUT rather? SUT stand for System Under Test. That's basically that. Within the testing space, okay, well, if not unit testing, so to say, like in testing in general, when you're testing something, you have that particular thing, we will call it, okay, this is our system under test, okay? So the system under test in the car scenario would be, your car is a system under test, okay? Then you're gonna test part of its functionality, which is starting up. So the same thing here. We test the bank account. The bank account is the system under test, okay? So, and we shorten it for SUT. Basically, that's just that. Then once now we have our bank account object, we then act. The first part was arrange, which is that whole making sure that the doors, you open the door, you got inside, then you close the door, whatever the case might be. You sat down, adjusted your seat, put the car key in the ignition. This is that portion there, the arrange. Now we are at the part where now you are turning the key now. You are acting. You are doing what you are supposed to be doing, which is testing whether the car starts up, okay? So that's basically that. That's what we're doing here. If this was car, our system under test was car, this would say SUT dot star or startup car or 10 car key, whatever the case, whatever the method might be named inside there, or 10 car on, whatever the case might be, right? But in this case, because this is a ATM or bank related type of thing, we're saying SUT dot deposit, okay? We're depositing and we're depositing 100 Rand, and we're making, once we're done depositing the 100 Rand there, okay, we go on to the next part here, which is the making sure part, that whatever we said here, okay, we said we're opening up with 200 Rand, and we're gonna then put in 100 Rand as a deposit, okay? Then we're making sure that this is gonna act as it's supposed to be doing. So our expected behavior is that this should be equal to 300. This plus that will be equal to that, okay? So because we know that this here increases our, the depositing here increases our balance by however much we depositing, then we're gonna go under the system under test and get the balance, okay? So the balance would be however much is happening in here, this plus that, it will be that, okay? And then the expected, the expected value is a static value, okay? We have to give it there. I'm expecting you to be 300. That's basically that. But if this here is not equal to that there, then this method is gonna fail. And that's basically that, okay? So this is me just explaining the AAA here, okay? Arrange, act, assert. And I've already covered what fact is here. So there's also one other marker that we have. This one here says fact. Fact is just saying recognize this as a test. But sometimes, especially around the mathematical portion of things, let me rather go in there and see if I did something of that nature, because it'll make sense in here. Yes, we actually have it in here. In here, we are doing the exact same thing here. But can you imagine if I wanted to, I'm gonna add, let's say 1 and 1, which the expected supposed to be, hey, let's say, for example, the expected supposed to be 2, right? And then I want to test if I'm adding 2 and 2. I can't be writing about 2 test cases for that thing, for that specific functionality. No. What do? You do what we call parameterized, test, right? So what does that mean? That means we can pass parameters, and then that test, depending on how many parameters I pass, say, for example, in this scenario, we have this here, 1 and then 2 and then 3. That means this test here is essentially 3 tests. This one test will behave like 3 tests, basically. So in this case, what are we doing here is the multiply function, right? So we're going to see that, okay, the first value, num1, is 0. We're passing it as a 0. Secondly, we're going to pass this one as a 2, and we're saying expected is a 0. So any number that you multiply with a 0 is supposed to be that. Well, that's what they say. I'm not sure, okay? So that part there, the expected is supposed to be that. So which means now this is going to run once with these values passed on, and then it's going to run for the second time with these values here to say the first one here, num1, is going to be 1. The second one here is going to be 2. And if I multiply that by, multiply those numbers, I should get a 2. That's what's going to happen there. And then likewise here. So this one is going to go in here. This one is going to go in here. And then this 4 here is going to go unexpected. Okay. So this multiplied by that's supposed to be 4. Can you imagine if we didn't have these here? If you're going to write it as a fact just means one test. That's basically, think of it that way. But now we're saying we don't want it to be one test. We want it to be parameterized or parameterized, or oh gosh, the word itself is like the tongue twister for me, really, to be quite honest. So if I want them to have parameters, right? So, or rather for that test to behave in a specific way depending on the values that I pass, I need not call it fact. I need to call it theory. Okay. Once I pass it as a theory, I mark it as a theory rather, then I'm able to pass the inline data marker there, and then it allows me to actually pass the values that are supposed to be there. And by the way, the values that you're passing in there, it's, let's say the parameters rather, it's 1, 2, 3. Those must match with these here. 1, 2, 3. So that's basically that. And then likewise, we're doing the exact same thing in here as well. We have calculator, it's our system under test. Then we say SUT.multiply, we pass the numbers here, and then we get the results. Once we get the result, we're doing the exact same thing here. We're saying expected, which is what we're passing in here, the last part of these values here. And then expected is that much, and then the result is whatever the results here. Okay, so that's basically that. You can never have an expected value that's dynamic, people. I mean, that wouldn't make sense. So that means any random value might be unexpected. So the expected value, what you expect must be firm, okay? It must be there. You are asserting that it's that one, hence the term assert, okay? We're confirming. If we're confirming, that means we expect it to be this way, okay? That's basically that. And I think I've covered almost everything around these here to explain the theory, explain the fact, and all of that, man. So all of those markers that I've explained, XUnit offers us those, okay? And basically that's why we need XUnit in there, or NUnit if you were using NUnit. You need NUnit in order to give you these here, the markers. That side they might not call it fact, but you will have something similar to that. In Java, they'll have JUnit, which does similar thing as well. It offers some of the markers there, so you're able to mark your method here as a fact or as a test, so that it can be discovered as a test by your test runner here at the bottom here. And all that I just explained to you here really is made possible by these. Let me right click here. As I click here, it just opened up. But if you don't get it, just right click on your project here and go on to edit project file. Okay, then you will see that we have these here. Okay, XUnit being responsible for giving us all of those markers and all those, think of it as it gives us the tools to be able to proceed with our testing here, such as those assert methods and those markers and everything like that. And this one here in particular, the XUnit.runner.visual studio, it's what allows us to have this portion here. Like this is our test runner here. So, and we're able to right click and run these methods here. So what makes that possible is actually this package here. And then what makes this portion here for us to have all these asserts and all these facts and all of that is actually this one package here. Okay, and MOQ, don't worry about it. Mark, we're going to explain it later when we dive into trying to separate our tests basically, to not test the other classes within this specific unit. Because when you look at a class here, this class here, think of this as a single unit, okay? This is a unit. Because in object-oriented programming, what makes up, what do you call this? What makes up an application? It's a class, basically. You need to have at least one class in order to have an application in the object-oriented world, right? Programming in C# or in Java for that matter. You need to have the minimum of one class. Even if I didn't have all those other ones, if I go under program.cs here, this is essentially a class. So even if you can say, hey, but I am able to come in here and write my little methods here and do whatever I need to do. But the minimum is that you have this class here, this class program, okay? So that's the minimum. I think, I'm not sure in Java they have, it's a main class, I think, or something like that, okay? So similar here, we have this as program, and then we have the main method here. Same, I think with Java, you also have the main method. It's the main class and then the main method, okay? So that's the basic that you need. So all those other classes that we had, like your banking account and all of that, allow us to actually to call them in here. So we can separate our code so we don't write everything all in one place. But what the main takeaway here is for you to understand that you need a minimum of a class in order to have an application within the object-oriented world, okay? Or in C#, let me rather say in C# or in Java as well. I'm not so much of a Java person, but I assume that to be the case, okay? So with that being said, a basic unit of an application here is actually a class of your application. It's a class. So think of your class as a unit. When we say unit test, think of it as class test. I think that might make sense. So that means you are just testing that class. As soon as that class calls another class, you don't test that part there, where we call in the other class, because now you are not focusing on that unit. Okay? Think of another way to think of it is that we have, let's say in South Africa here, again, 10 rands. Okay? What is the unit that makes up that 10 rand? 10 rand is the whole, it's money on its own, right? But what makes up that 10 rand? It's actually a multiple of rands. So, and it's 10 of them. Think about that. So if to make sure that I have 10 rands, I have to count each and every single rand and say, okay, 1 rand here, 2 rand here, 3 rand here, up to 10. Then I know that it's 10 rands, assuming that it was coins, by the way. So, because somebody will say, hey, but I can see the note. But think of that concept as from the perspective where we're having rands, like your coins. Those coins, a single coin, is actually a class on its own, okay? And that makes up your, 10 rand. And think of it another way like this. If you think rand is a class and then we actually duplicating whatever. Think of, we had 10 rand and we have and it's made of 1 rand coin and a 2 rand coin and a 5 rand coin, right? Maybe 1 5 rand and 2 rands, and then you have 1 rand, right? So that makes up our 10 rand, right? So 1 rand will be a different class. Let's say in this case, it will be our banking account, and 2 rands will be our math account, our math or whatever the case might be, and 5 rand would be our service class day, right? Those need to be tested separate. You can't be testing them as the same thing. We don't test that way. We test one specific thing and make sure it works and go to the next one. Then later on, we might just sit down and say, okay, let me just see all these things together, right? Now this is me taking my 5 rand and my two rands and then my 1 rand. When I put them together and I go and buy at the store, they're 10 rands. I'm like, hey, I need this, whatever, assuming that whatever you're buying is worth 10 rands, okay? It's the same thing here. Our application is made up of multiple classes, and we're going to test each and every single one of them. And then once now one class called the other one, we're just going to fake that functionality there so that we don't really get concerned about that other functionality. We assume that it's working, right? But once we are done with our unit test, then we might want to see, hey, okay, let me see, my class is working here. Let me write another test that actually check this class of mine. Okay, it is working again. But now, over and above the other one that I did when I did my unit test, now I'm actually calling the actual class here, the other one. Like in this case, the bank account was calling that notification service. When we do that now, that's me now integrating with that other class. If you think about it, that's my bank account now integrating with the notification class. And that's essentially our integration test. Okay, integration test doesn't need to be just another class as well. If we're calling an external system as well, that's integrating, because you're no longer focusing on this one thing. This one thing speaks with another thing that has functionality that this one thing of ours, our class, doesn't know of, but only that other service or that other class know of. Okay, so that's basically why we call it integration test, and we call just looking at one class unit test. So from here on, you can think of unit test as class test. Okay, class testing, unit testing. Okay, we're testing one class. And then we have integration testing. When we're seeing that both classes are actually communicating with each other correctly, then we can consider that to be, I don't know, you can, our integration test, you can consider them to be, think of a word for it, man. Actually, let me give it to you as a homework there. Say it on the comment section there. Let me know what you might want to call it, okay? I came up with mine there off the top of the head here, and I called it class testing. So the other one, I don't know. Don't say multiple class testing, please. Think of something else here that might be fun for somebody else to actually think about. In that note, I am done here. The session actually was done a long time ago. This was just to make sure that we understand, making this more relatable as opposed to me just diving into code and doing all sorts of other things. In that breath, I am done. You have a wonderful day. Le tlhogonolo, botsa tlhogi.